So here we're looking specifically at the mechanics of breathing. And so I want to start out with, of course, some of the key functions of the respiratory system. Now, do you have to have this all in detail? Of course not. But you need to understand what each of these key functions are related to. So obviously the main function is gas exchange, exchanging oxygen and carbon dioxide, bringing it in so that it can be taken to the tissues of the cells. And of course, we have breathing, which is that mechanical process where we're bringing air from external body into the lungs and then removing the air out of the lungs back to the external system. Sound production, such as I'm demonstrating right now, is another function that we want to focus on. Obviously, as the air is moving across the vocal cords, which really are actually folds, not cords, but in the larynx, that vibration allows us the ability to create sounds that we use for speech and communication. The respiratory system air conditions the air. So as you're breathing air in, it starts tumbling, it's moved through the system, it will be warmed up, and it is humidified so that it's going to be have more moisture to it. That's part of the reason when it's really, really cold and you exhale, it looks like you're smoking, because the warmer, moisture air causes that formation of the fog or mist. Olfactory assistance. The nasal cavity has a lot of pieces that are areas, the olfaction sensory receptors, that are picking up particles that are in the air. So when we bring it in, they get caught in these sensors, and we can then process the smells. Protection. Respiratory system has mucus, it has cilia, it has all of these things that are trying to trap and remove foreign particles before they actually get into the system and can cause problems. And these are all throughout the respiratory system, trying to keep things that shouldn't be in there in there. And it also plays a role in acid-base balance, because the pH of the blood has a significant contribution based on the amount of carbon dioxide in it. And so by controlling the amount of carbon dioxide that's still in the bloodstream, we can adjust the pH of the blood. So now that we know kind of the key functions for the respiratory system here, we can look at the basic process of respiration. So to understand this, you need to think about the fact that between the outer surface of the lungs and the inner thoracic wall, we have a space. It's called the pleural space, and it's typically filled with pleural fluid. So it's making this kind of seal. And the idea with this seal is it's keeping pressures set at a certain level. And so then as we adjust pressures, it allows it to move. So during breathing, certain muscles will contract or relax, and as they contract and relax, they change the volume of the thoracic cavity, and that change in volume changes pressure, which is what actually allows air to flow in and out. So you're not really pulling air in and pushing air out, you're changing the volume of your thoracic cavity to allow the air to flow. Now, within this concept, most of that is a more passive process, but we also have what we consider forced breathing, where we can actually use additional muscles to further expand or further contract the thoracic cavity, allowing us to bring in or remove more or less air. So I want to jump over here to one of the gas laws that plays a huge role in this process, and that is Boyle's law. Boyle's law states that the volume of gas is inversely proportional to pressure. Inversely means they're going to move opposite. And this is when temperature is constant. There are some other things that happen if we start playing with temperature, but we're not actually, we're not going to calculate these things. It can be calculated. That's just not something we're going to do. So the idea here is, like I said, these are opposites. So when the volume of the thoracic cavity increases, the pressure in the lungs decreases. And because the pressure goes down, that's what's actually going to allow air to flow into them. When the volume of the thoracic cavity decreases, so it gets smaller, the volume of the lungs decrease and the pressure increases, allowing the air to be pushed outwards. So when we're talking about inspiration specifically, so this is the phase where we're bringing air into the lungs. And so it starts with the contraction of two key sets of muscles, the diaphragm, which of course is just below, it's going to flatten out, and the external intercostals are going to kind of elevate the ribs and sternum. They're going to allow the chest cavity to move outwards. This increases the volume in the chest cavity, therefore increasing the volume in the lungs and decreasing the pressure. So make the chest cavity bigger. That means we're making the volume bigger. The pressure goes down because Boyle's law says one goes up, one goes down. Pressure goes down, so now the pressure in the lungs is less than the pressure outside of the body, causing the air to move inwards, trying to balance out that pressure. We're always looking for that balance. Now, if we move into active inspiration, remember we said that this is where we use extra muscles. We call these accessory muscles that will increase the volume in the thoracic cavity even more. So the scalenes, the sternocleidomastoid, pectoralis major and minor, serratus, latissimus dorsi, all of these additional muscles are going to do their own amount of pull that further increases the thoracic cavity. And remember, the greater the volume, the less the pressure, because they're going in opposite, which is going to allow even more air to flow in. So it's all about air flowing. It's not about pushing and pulling. That's what the muscles are doing. Well, they're pulling because we know muscles don't push, but do you have to know all of these specific muscles in detail for our course? No. Were you to be taking it at a higher level, they're going to expect you to know it. Okay, and so that takes us to expiration, which is where we're removing air, or air is going to be expelled from the lungs. And so ultimately what's happening is our key muscles, the diaphragm and the external intercostal muscles, are going to relax. And when they relax, they're going to shrink down. We're going to have a smaller volume. When the volume goes down, the pressure goes up. So now there's more pressure in the lungs than there is outside of the body. So air is going to flow out of the lungs until we get a balance where we have the same pressure inside the lungs as we have outside the body. So remember, inspiration, we're increasing the volume, allowing air to flow in because the pressure went down. Expiration, we're decreasing the volume, pressure goes up, which is going to cause air to flow outwards. And the idea is we're always trying to balance the air pressure outside the body versus inside the lungs. All about that gradient. Now, just like we had with inspiration, we also have active expiration, and we're bringing in additional muscles that are going to help decrease the volume. So the anterior lateral abdominal wall, the internal intercostals, and the innermost intercostals will actually contract, decreasing the volume. When the volume goes down, the pressure goes up. So that's going to make the pressure difference between inside and outside, which is going to cause the air to flow more strongly. So one other thing that we really need to mention in relation to this process is Dalton's law of partial pressures. Once again, this is something that is calculated, but we're not going to do it in this class. But the idea here is the air that's around us is not just oxygen or not just carbon dioxide. When we're talking about air, we're talking about there's a whole bunch of different gases mixed together. So Dalton's law is basically saying that in a mixture of gases, so nitrogen, oxygen, carbon dioxide, just any of the gases that are found in there, the total pressure equals the sum of the partial pressures for each of those gases. So the pressure of nitrogen plus the pressure of oxygen plus the pressure of carbon dioxide plus the pressure of, we add these all together, and that tells us what the whole pressure is. Okay, so how this applies in this concept of respiration is that in the air in the lungs is a mixture. We're focusing mostly on oxygen, nitrogen, and carbon dioxide. They make up the greatest percentages for the air that we are just breathing. And so we use these partial pressures, the pressure of oxygen, the pressure of carbon dioxide, to determine and control how the air moves across the capillary and alveoli walls to do the gas exchange. So this is what's kind of helping us figure out what direction does oxygen flow, what direction does carbon dioxide flow. And so partial pressure of oxygen in the alveoli, if it's higher in the alveoli than it is in the blood, remember, we're always trying to go from high to low till we get them balanced. So that causes the oxygen to move from the alveoli into the bloodstream. We find the same thing happens with carbon dioxide, except typically the carbon dioxide is higher in the blood than it is in the lungs. So it's going to flow out of the blood into the lungs, which then we can exhale.